Good day, friends. You are welcome to Abona Mathematical class, home of academics. Today we'll be discussing a mathematical topic called logarithms. Like this question on the board is a particular question a student gave to me on logarithm. This logarithm is embedded with trigonometry. You can see sign part of trigonometric ratio. This is a logarithmical notation. Now, to solve this, we are going to analyze, combine two topics together, which is logarithm and trigonometry. Now, before I go, logarithm is a topic on mathematics. We got the word logarithm from two Greek words, logos and arithmos. What is logos? Logos means reasoning out. What is arithmos? Arithmos, these two words are Greek words, which means numbers. Now, what is that? Logarithm was established in 1613 by a Scottish mathematician, John James Napier. This man was a great philosopher, a farmer in Scotland that discovered what? Logarithm. He was born in 1550 and died in 1617. And logarithm has two notations. We have logarithm in base 10 and logarithm in base e. This logarithm in base 10 and base e, these are the two types of logarithm notation we have. Now, logarithm in base e was designed and established by John James Napier, which is also denoted as lane. Now, after that, after his own era in mathematical world, after his death, another philosopher took over, which is what? John Henry Breeze of England was the one that designed log in base 10. Log in base 10 and log in base e, they are not the same at all. Log in base 10 is called common logarithm, or I call it Briggian logarithm. Briggian log. Log in base e is called Naperian, from the man's name Napier, or hyperbolic logarithm, or I call it natural logarithm. That is what I want us to know. I just quickly run commentary on what logarithm is what all about. And we have what we call logarithm notation. Logarithm notation, we have what we call traditional notation. Two types. Traditional notation, which is log comma b. Now, here is the base of the logarithm, while here is the number. This is the olden days way or ancient way of writing logarithm, which was designed by this man here, John James Napier. Now, after his death, another scientist came, which is current notation of logarithm, and that is the way we denote logarithm now, which is log in base AB. My base here is A, my number here is B. My base here is A, my number here is B, and this is the way we write logarithm in this dispensation. Now, we cannot see this question on the board. 6 log 6 comma sine pi minus y is equal to 1 over log 6 comma 6. Viewers at home, very funny question, because this is the way they want us to solve, and it is denoted in what? Traditional notation. Now, I have to rewrite this logarithm in current notation before I can solve. 6 log in base 6 sine pi minus y is equal to 1 over log in base 6. Now, I'm going to twist this one too, which is log in base 6. Initially, viewers at home, this notation, they are denoted in traditional notation, but I have to put them in one current notation. There's a particular law I'm going to use in logarithm. I call this law double base law. I call the law double base law. That is the name of the law. How come double base law? Because the base, initial base is A, and the base of the logarithm is A. That means they marry each other. The answer is what? X. Now, that's why I'm going to cancel this. I have sine pi minus y is equal to 1 over In logarithm, when the base and number are the same, the answer is 1. From there, I saw sin pi minus y is equal to 1. I can solve this aspect 2 times. I can approach it 2 ways. Now, I want to get my y. I will take sin inverse of both sides. Pi minus y is equal to sin inverse of 1. Pi minus y is equal to sin inverse of 1 is what? 90. I will now make my y the subject formula. I'll bring this here and bring this one out. Pi minus 90 equals to 1. This is the answer, but we should note it. Our pi here is in pi radian, not pi as 22/7. Under mensuration, pi is 22/7. Under trigonometry, our pi is in radian, which is 180. Therefore, 180 degree minus 90 degree equals to 1. 90 degree equals to y. Therefore, y equals to 90 degree. That is the answer, which is option C. Well, as I've said, I want to take the second part. I said we can approach this question in 2 ways. The first method is to take immediately the sin inverse of 1 immediately. That's what I've done. The second part is I'm going to use what I call trigonometry identity. From here, sin pi double angle is equal to 1. Now, second part, I'm going to split it. Trigonometry identity is sin pi cos y identity minus cos pi sin y equals to 1. Now, initially, the first method, I said pi minus y equals to 1. I took the sin inverse of this, pi minus y equals to sin inverse of 1, and I got 90 here initially. But this one is another method we can use to approach this question. Now, I want us to know pi is pi radian here. Why am I using pi radian? Because of the sine, one of the trigonometry ratio given to us. We have 6 trigonometry ratio. SOHCAHTOA and CHOHCAHTOA. Here is sin theta, here is cos theta, here is tan theta, the first 3. Here is cosec, here is cosec. This side is sec theta, while this one is cot theta. Because we are giving one of the trigonometry ratio, in trigonometry per se, our pi is in 180. Under mensuration, our pi is 20/7. I replace this one now, sin 180 degree, cos y minus cos 180 degree sin y equals to 1. My sin 180 is equal to 0. Is equal, note, sin 180 in trigonometry is 0, y cos 180 is equal to minus 1. Now, I put it 0 cos y minus 1 sin y equals to 1. 0 times cos y is 0. Minus is plus. 1 sin y equals to 1. Finally, at this juncture, I multiply. 1 times sin y is sin y equals to 1. I'll take the sin inverse here together. Y equals to sin inverse of 1. Y equals to 90 degree. That is the second method or the second way to approach this question. Thank you very much, viewers at home, my friends, all over the world. Go to my YouTube page, like my video, share it, including my Facebook, so that people all over the world will know what I'm doing. So that you will be the first partaker of my video when I drop it on my YouTube page and on my Facebook page. Thank you very much. Bye.